Hi, everyone. Thanks for coming back again. This is a real special one because this is actually Ken Shoulders number 50. So it's amazing that we've actually done 50 of these. And today we're going to go into, um, we'll call this Ken Shoulders number 50 and teleportation number 3. So this one is going to be mostly on teleportation. And what we're going to go through is the receiver for the Montauk project. And that receiver is an FRR 24. And I was able to actually find the manual for it. It's a 950 page manual. And I do remember sending it to John Hutchison, and he was super excited to get it. So, what we're going to do today is just kind of go through some of it, just to show you what it is and some of the electronics. It is all vacuum tube electronics, which it has to be because they're running everything at high voltage potentials, and there is no other way to do it other than with vacuum tubes for all of this stuff. So it's part of the Montauk project. This is the actual electronics that made it work. So cool, Brendan. Let's jump into it. Here we have the Amplitron, and this. Um, so when I actually first got a hold of Peter Moon, I asked him what tube type was in that Amplitron, and he came back and said, it's too bad that Preston Nichols isn't with us now because he would know that. So Peter Moon didn't know the tube type, but I do know that this tube is like 6 feet long. So this is a very special amplifier, ultra high frequency amplifier. Um, I believe that there were multiples of these, because I do remember Al Bielek talking about, um, there could have been a few of these. So let's keep going, Brendan. So this is the final output that drives the transformers. Now, to drive the output, they have to drive, or they use four of these in parallel. And Paul, I know that I think you actually showed me a Thyratron once. So could you explain more about what a Thyratron does?
Uh, yeah, there's well, I just got one right here on my desk.
There you go.
It's a giant one from
I'll just
it's
stop
a
the share.
Russian.
I'll stop the share whilst let me just have a minute. I'm going to say uh take that down. I'll stop the share. If you're talking, it will show your screen.
Oh, okay. Yeah,
Yeah, yeah.
basically.
Maybe you can show it again because yeah.
Yeah.
You have to talk for it to show your screen.
Right. Okay. Yeah, it's a really big sucker, and it uses hydrogen inside, so it's hydrogen thyratron. The hydrogen gets stored in this little cell here, and when it heats up, it releases the hydrogen into the vacuum.
Yeah.
And basically, it's a switch essentially, and it can switch very high voltages, 25,000 volts, 50, I think about 50 kilohertz or so. Uh,
Okay.
and then,
And what
but it
I
can
saw
dump
the
a lot of
numbers.
current. So it
I
can dump a lot of current.
I saw the numbers on it there. What
Yeah.
number is that? Just out of
Uh,
curiosity.
it's in Cyrillic, so I think it's a G U 1725.
Oh,
So
it's a GU, so that's a Russian
yeah,
tube, isn't it?
yeah. So it'll do.
Cyrillic.
Yeah, so it does
Wow.
25,000 volts at 700 amps. So,
Jesus.
so that's what's crazy about these things. You can jump megawatts of power
Holy.
instantaneously. So you can provide a really quick pulse.
Yeah.
And
I,
yeah, that's
no.
essentially what they do.
Yeah.
And so what they've done in the Montauk project is they've used four in parallel. So that's probably to get the amount of current that they needed.
Yeah.
That one almost looks bigger than the ones that they used actually, like this one. Did you, yeah, back it. Yeah, I think that one is bigger than even these ones. Very interesting.
Yeah. Yeah, and then I think the biggest one I have does 25,000 volts at 1,000 amps.
Wow.
So yeah.
Are they liquid cooled or anything like that? Is that one liquid
No, that
cooled?
one's all in ceramic.
Oh, okay.
Yeah, and that's like the terminal on the end
Yeah.
for the plate.
Yeah.
And
For the
then it's
plate
all
voltage
ceramic, right? So the high voltage doesn't
arc
seem to
over.
arc over. Yeah.
Yeah. Wow. So this is basically the driver stage that drives the amplitron at the final amplifier, essentially. I believe that's what they were saying. And it was frequency hopping that made the mind control and bending of time possible. Again, Paul, I'll ask you what, because you're really the expert here when it comes to this stuff.
Yeah. Well, basically, what they were trying to do was take the thoughts of the person who was in the Montauk chair, and Duncan Cameron was one of those people, and they were basically experimented with psychic people. To back up, this whole project started with invisibility, to be invisible to radar, of course, with Project Rainbow and the USS Eldridge and all that.
Yep.
But as it evolved, they realized that they were going to be, the ultimate goal was to want to be able to fly spacecraft like the extraterrestrials do, and fly it with their mind.
Right.
And so
Right.
that's where all this research started coming in, how it started. But then they realized that they could, so what they needed to do was collect people's thoughts and their intentions, basically, and then store it in a computer and then be able to project it outwards to make it happen. So that would be your interface with the spacecraft. So you could say, I want to go to, you know, Mars or whatever, and it would just think, you would think it and it would go. So that
Yeah.
was their ultimate goal. But all this stuff came out of MK Ultra and mind control projects and stuff like that, is kind of where it all started. So yeah,
Yeah. And also the Nazis too, right? I mean, it's really
right.
started with them because this whole project was actually ran by them. A lot of people don't understand that.
Yeah, well, Project Paperclip, they all came through Montauk there at Camp Hero. There was underground
Yeah,
caverns with submarine bases. So
yeah, exactly.
yeah,
So here we have something very interesting, and this is actually from John Hutchison, and it's the schematic of the equipment that he used to heal the water in the Gulf of Mexico when the oil spill came along. And one of the things that I first really, when I saw this setup, and Paul, we know that everything has to be in perfect phase. And look at the way it's all connected. It's all connected in parallel because
right.
that center connection is Brendan. Could you maybe bring it out so it shows the whole thing?
That's great that it has all the frequencies on there. I've been that's one question I haven't been able to answer for myself, is what were the frequencies they were
Yeah,
using?
this is what he's using. But you can see the speaker wire and how the plus and the minus goes all the way straight through and connects to everything. So everything is pulsing, I guess, in phase at least, right?
Yeah,
He uses multiple antennas, an RF amp. Um, there's a lot's going on here, eh?
yeah, and there'd be a lot of harmonics and interference patterns and stuff. It's like a
Yeah,
yeah,
exactly. Yeah,
interferometry kind of thing. Yeah,
yeah, because it's
Interferometer is a bit like the Michelson-Morley experiment. Interferometer, similar.
yeah,
yeah,
Or,
and you can
or
actually
the
see
silver tooth, whatever. Gone.
the interferometer on the left-hand side, the fourth thing down, where it says sweep. Yeah, right there,
yeah.
signal sweep generator.
Right. And that's sweeping through the frequency bands. So that creates the interference patterns as it goes. Yeah.
Right. So 200 to 500 megahertz, um, 1.5 gigahertz on signal generator number four. Number,
Microwave. Yeah.
yeah, Mike, yeah, 1257 megahertz. And then 16 kilohertz. That's interesting. Signal generator number eight. So that's you can hear, most people can hear 16 hertz. I don't know if I can anymore, but um,
Yeah.
very, very interesting.
What kind of antenna? What's
Well,
the
there's
antenna like?
multiple antennas. Look at them. There's one, two, three, four down that side, five, and
What
This
kind?
six,
was
seven.
John's. Well, John had multiple things set up, like one of the thing that he called the wave shaper, and it had like toroidal coils on it, separated by insulators, and it was a stack. But he had a combination of DC high voltage Van de Graaff kind of generators,
Yeah,
and combined with Tesla coils and several different coils were all over his scenario, and he'd move them all around and look for the sweet spot where the waves were interfering. Because
yep.
I think John was able just to intuitively have a feel
I
for those things.
exactly.
And he listened on the radio, and sometimes he'd watch on a TV on an old CRT screen as well for
Oh,
weird
okay.
ones. Yeah.
Yeah, yeah. But I think you're right. He was just so intuitive that he just knew where to put stuff after,
Yeah.
years and years. And I don't know if you guys have watched him in the last couple of weeks, but he has
Yeah.
been doing some crazy stuff again. Oh my God. It's
So
Yeah.
awesome.
he built this. John Hutchison built this.
Yeah, John
Yeah.
Hutchison used this setup right here when he went to the Gulf of Mexico and he cleaned the water with this setup. That's what this is.
Oh, okay. So this would be from his, yeah, where he has his ray gun set up and the mobile rig that they had in the
Yep,
truck then.
yep,
Oh, okay. Okay.
yep. I think that's what this is. Yeah.
Right.
I found it in. I've got a kind of a link to some of his papers and stuff, and
Yeah.
I found it in there. And when I saw it, I was like, "Holy cow!" I was just like you. The frequencies are on here. It's like
Right.
amazing, right?
Yeah. Yeah.
But we really need the man himself to decipher it. I mean, being realistic. I
Well,
did. I
how
did
did he
invite
come
him.
up? How did he come up with this? I mean, he must be channeling. This is way beyond our science.
The Hutchison
Way
effect.
beyond, yeah.
Yeah.
Yeah, he's a genius. There's no
He's dialed
question.
in. Yeah. He's
Yeah,
dialed into it for sure.
Dialed in.
Yeah.
Dialed into something for
Yeah.
sure. If he's
he's
actually built this and tweaking it,
Yeah.
playing games of fine tuning everything on these signals, for example.
yep,
He's
yep.
you said perfect phasing, which means your frequency has to be adjusted just right.
So I'm still new
Uh,
to this. When you're saying he's cleaning the water, what is it doing?
Um, I think
Ju-
at a molecular level, he's doing something. What do you
Well,
think about that, Paul?
he did two things. Like around that time, there was the Gulf of Mexico. You remember the big oil spill, and
Yep,
oil was washing up on the beaches, and birds were that. They went down there and pulled up to the beach, and basically in the back of a cube van had this whole setup,
yep,
and then projected the beams out into the water to disperse the oil to break it up further. So it had environmental remediation kind of system, right?
yep,
And then when they were on the West Coast during Fukushima, that was the other one, when a lot of that radiation was coming over and dumping everywhere in the rain, and that coming over from Japan. They used it then as well to
Dissipate that.
clean up their area.
yep,
Yeah.
But
yep.
then you say this also has something to do with thought control.
Well, um, this setup here
Does
probably
not.
does
Yeah.
not. Yeah.
Okay.
No, this is his setup, and you can see at the bottom it says three speakers, one over water. Oh, yeah, one over water, one in ground in creek, one over land, over water. So, and I do remember there is actually a YouTube that goes with this, and there's an article that was written as well. Maybe another time we'll go through the article and read through it because
Well,
it worked.
it's really interesting there. If they were throwing a cable in the creek, that's essentially what Wilhelm Reich was doing with his Cloudbuster, right? So a
Oh,
Cloudbuster was essentially an array of tubes, usually aluminum or metallic tubes, and it looked like a cannon, and they could adjust it and point it around up in the sky. But what they did is they took BX cable, BX armored
yeah,
cable.
yeah, yeah.
So in industrial and commercial
Wiring.
wiring,
Yep,
it has a aluminum shield that wraps around it like a spiral. And so they pull the wires out and take those aluminum shieldings and on the bottom of each pipe, you basically take one of those spiraling pieces of aluminum in a long tail, and you throw that into a creek, into a water
Oh,
source. And
wow.
that's the secret to building a cloud buster, basically. What you're doing is causing a capacitive, and then there's some inductance, of course, with the coils and the spirals that are jumping into the creek, but
Yeah.
providing a ground base with those antennas projecting up at the sky, and that basically takes that charge from the earth and then pushes it up into the air and then parts the clouds in the sky.
Would it be safe to say that what's being projected out is charge clusters?
Well, right,
Or
called them bions or ergon, right? Everybody has a different name, but they are all these things. I look at them; they're all charge clusters.
yeah,
What's the
ex-
balance in that charge? Is it mostly ionic? Is it mostly electrons? They can vary, right? You can have a lot of different ones. So the way I like to see it is charge clusters is like the overarching thing you can call them,
yeah,
and then everyone had different names for them over the years, and yeah, essentially Wright called them bions and said it was orgone energy.
yeah,
Yeah.
Yeah,
Rather than charge clusters, meaning the plasmoids that Muslim that was invented by Bostic, you say there's something more fundamental going on in the ether.
yeah,
Whatever's being made, the flow of the creek and everything else, and there's obviously some type of spiral thing being induced. But
yeah,
we're basically beyond our science and etheric type of engineering, and so it may fundamentally something's going on. It may have that donut shape, whatever it is. But we're off on the new science, something more, say, more fundamental than the plasma form that Shoulders investigated. There's something
yeah,
obviously more fundamental than this. And
yeah.
if Hutchison actually came up with this, there's something, and he's channeling. There's something very sacred about him, and it's why he's not suppressed. They want, the
Yeah,
powers that be want whatever he has coming through him.
yeah,
I
yeah,
mean, he's leapfrogging into stuff well beyond our science,
yeah.
way
absolutely.
beyond what we know.
Yeah,
And
and
so,
they have used his stuff in like the original Star Wars project with Ronald Reagan,
Yeah,
evolved into the Golden Dome. That all ties back to Montauk, where you see where all that stuff kind of comes from with those same kind of ideas, like let's make a ship, a Navy ship, or an airplane ultimately invisible. That technology evolved into the B-2 stealth bomber and
yeah,
how they do the cloaking today. And it started out as being invisibility to radar, but all of these things go to this defense shield, the Golden Dome, as Trump
yeah.
likes to call it today. It's all part of evolutions of the same kind of technology.
Yeah, absolutely. That's definitely the case. So Alan just joined us here. This is I don't know if you've ever seen this. This is John Hutchison's setup
Oh yeah.
that he cleaned the water with in the Gulf of Mexico when they had the oil spill.
Mm.
And we were just kind of looking at it shows all the frequencies and the one thing that I noted right away was that everything is in phase, just the way it's hooked up. With the plus and the minus, you can just see that everything needs to be in the proper phase, right? That the speaker wire line the blue line that goes through the middle there, everything is connected to those.
Oh, I see.
Yeah.
Yeah, no, this
Uh,
is great. Thank you. So I'm sorry about missed the first half hour. Was this
no.
leading up to this?
We actually just started just a little while ago. Yeah,
Oh,
yeah. So yeah, you're right on time, especially for this, because
mhm.
I should assume when it says 1420 M hertz, that's megahertz or not millihertz, megahertz, yeah?
Yes.
yeah, and then
Mega, giga, kilo. Yeah,
yeah,
killers.
there's gigahertz below there.
So does anybody sense that there's a way to produce golden ratio pulses out of this mess?
Well, you know what,
What?
Chip? That's a good point because maybe that's partly what he's doing,
That's a great point.
Yeah.
Exactly.
right?
Jesus.
Yeah,
Right?
I
well,
mean,
it'd be
this is
great. Yeah, if you got out the calculator and then wrote all the frequencies down, you could probably see some
that's
patterns.
probably what's happening, Paul. Yeah.
Yeah.
Makes sense.
I'd like to get the man in here. I did invite him this morning, but I think he's not a morning person, so we'll have to get him another time. But yeah, this is fantastic. I don't know if this has ever been shown to anybody before. When I found it, I was very, very excited to see it. And we'll come back to it, I think. But let's keep going because we have a whole bunch of stuff to cover today. So this is the manual for the FRR 24 receiver that was part of the Montauk project. And you guys are going to see that it's not just a single piece of electronics, it's actually a whole wall full of electronics. And this was 950 pages. I do remember when I sent it to John Hutchison, he was really happy to get it. And I sent it to Paul and Alan. I think you guys have
Yes, I got it.
Yeah. So what I did is I just went through here and took a bunch of screenshots of some of the more interesting stuff. And now that you guys are here with me, we'll just comment on what we kind of know and whatnot. But yeah, this is really cool. So FRR 24.
Whoopsie. Well, I'll just general description: restricted Navy ships.
Oh, could you go to the one just below the, you're jumping a little ahead for us here.
Which one do you want to go to? The one at the top?
Yeah, the one just below. Yeah. Is there one above that?
No, there's nothing above that.
Okay.
So
That,
just, I mean, I don't know if you can read it.
yeah, we don't necessarily have to read it all. I just wanted to show the complexity of it all. Some of the other screens, hopefully we can read. I'm not sure why we can't read them.
So, who designed this
Nikola
electronics?
Tesla.
Okay.
Yeah, this was Tesla's work. He worked for RCA, and he retired from RCA as the vice president of worldwide engineering in 1939. And this is all Tesla himself here. Now, the interesting thing about this receiver is it's not just set up for Montauk, it's set up to do a lot of other things. So there are many different functions that are in here, and that's why there's these charts that show like this is how they hook it up for this type of circuit. This is how they do it for something else. There's many different things, but it does show you like one of the things I see right now is 12AX7 DC amplifier. That is a miniature tube that is super, super common in audio. So is the 6C4 DC amplifier that's beside it. That's another,
That one there.
yeah, that one there. And so it uses some fairly common tubes in some places. I know that there's 420 tubes in this actual setup, and I think there's a screenshot that will show it a little bit more. The
So
yeah,
let's go on to the next one.
yeah. You guys can jump into
Do they mention the gas that's in the various tubes?
well, most tubes don't have a gas in them. They're just a pure vacuum, right? They,
Or
they
the
draw.
Concord, right?
Yeah.
But some do have gas in them. No, those will be very interesting.
Yeah, like the one that Paul just showed us, right?
Right.
Yep. Yep. Some of them do. So this one is really interesting. I want you guys to chime in on this because there's
Yeah.
diodes here,
Yeah,
right?
and while we're on the schematic here, so you see these circles, they're the picture of the tube, and in there you see the anode and the cathode and the grid.
Yep.
What they'll do if there's a gas in it, you'll see a dot. They'll put a dot inside of that circle, and that means it has a different gas in it.
Oh, okay.
Not
Cool.
a vacuum, yeah.
Yeah. And these are so combining diodes. So this is it's a double diode. That's why there's that dotted line through the middle, and there's two circuits there. And I know that I've seen diodes used to do noise cancellation and some things like and I'm not even sure what's going on here, but I just brought it up because it looked really interesting, right? Yeah.
We're basically taking multiple signals in and being able to mix and combine them and make very complex signals.
Have you anyone that's heard use of a white noise diode?
Yeah, actually, I think I have heard of.
Because that would be very key to Montauk.
Yeah,
stuff.
because I know at Montauk, and we're going to go through that in a second here, there was 100,000 watt white noise amplifier that was part of the Montauk project, part of this electronics, right? So, yeah, that's really, really interesting. So what do you guys think? What are they using the white noise for?
Oh, I can tell you that.
Perfect.
Because white noise auto correlates to 50% of anything
Of the
or
frequencies.
everything.
Yep.
Because it's a totally random function.
Right, right.
It's like background radiation. If you look at your spectrometer and you're looking for a signal, it'll show up as a peak in the signal. But if you zoom down into that noise floor, just background cosmic radiation, everything from, Schumann frequencies in the earth and everything like that. There's a noise floor at the bottom and everything's going like that. So it's a wide spectrum of every frequency all at the same time.
Yep.
Yeah. It's typically in again addressing acoustic seismic processing, we use it to essentially white noise is used to drive a recursive algorithm and then look at perturbations and as it is converging on solution and eigenfunction fields and things like that. So you need some kind of a universal base. That's what it is. It kind of sets a bias for everything.
Right.
And then like Paul says, you get any frequency out of it.
Yep.
This setup almost looks like it's attempting to heterodyne something very quickly to very high frequencies.
Let me add one more thought on the noise. If you're really amplifying the noise, extremely unusual to do in electronics. The thought that occurred to me, psychoactive was the word that popped into my head.
Okay.
When you amplify, all of a sudden the mind is able to interact with it. So
and it's
be careful
just
what you wish for.
It seems non-intuitive, but being able to identify
it's amazing. Amazing that you want to do that. I mean, anybody who does any signal processing, it goes the opposite way. You're trying to suppress your noise and get your signal out.
Yeah.
Here you're going the other direction.
Yep.
So that's mind blowing because you asked the critical question, Ed. What's the purpose of that?
Yep.
Usually you want to work on the signal, right? But to do that properly, as it turns out, you need to characterize the noise.
Right.
Yeah.
I guess
shit outside of the Gaussian curve.
Well,
exactly.
Characterize versus amplify. That's the mind blowing part, right? I'm amplifying it, right?
Yeah.
All right. So you ask a hell of a good question, Ed.
Yeah. So let's keep going. We'll just keep looking at stuff here. Combiner. 12AT7, that's a medium gain, again, little miniature triode or twin triode. That's why there's two setups there. And combining, see, that connects to the combining diodes. They come in a couple different spots there, right? So this almost looks like an amplifier to amplify what they've got going on with the diodes, perhaps.
Yeah, they're running parallel, but
is this typical? Having duals, is this normally occur?
Yeah.
This first time I've seen it.
Yeah,
and because you want them to interact, right? Obviously, you're in the same environment.
Evolved. Yeah, they started off as single triodes, and eventually they figured out how to make two of them in the same package, which was you can just combine a lot of the circuits. So
yeah, you can run them different ways. You can run them in parallel, or you can run them like in push-pull. Sometimes we'll use one for push and one for pull.
Yeah.
So there's that's the one thing about tubes, you guys. There's lots and lots of different ways to operate them, and that's what you're going to see with all these schematics that keep coming out of here, right? And this is just a sliver of what's actually in there, right? And you'll see the whole rack system in a second here. So yeah.
My question is, do you actually intend for these two plasma events to interact with each other? Or it's just a convenient manufacturing thing that they behave and you control them independently and don't expect them to interact. It's like having two separate tubes,
I
and your goal was, oh, just it's more convenient to manufacture, or
Yeah.
your goal is, I want them to interact with each other.
I think
in
it
a
was
specific
both.
way.
I think it was both actually, because they were trying to miniaturize things, and that's why they put two. You can even see some tubes that'll have 3 sections, and then it'll even have a diode in it. So there are tubes that have multiple functions, but also I think it's both, right? So they're
Yeah.
trying to make them smaller, but they're also using them for push pull and op amps is another function of these twin triodes, right? Personally, I don't actually like them. I like a single triode when I do audio myself,
Keep
right?
that separation. Yeah.
Yeah, yeah,
So,
totally.
Yeah.
here's another question. Could this be recreated in purely solid state equipment?
That's a
No,
good question.
I don't think so. I actually
Yeah.
don't think so.
Well,
Yeah.
you have your power problems, of course. You're trying to do large power, but the other is you want to influence the plasma in the tube, and that's why I'm asking the gas question, because
Yeah,
once it's
that's why I
ionized, you're
asked, yeah.
moving the heavy particles, and that is the key. Keep that in mind. These heavy particles and what they're doing is the key for activation, ether
Yes.
activation. And
Yeah.
so keep that in mind. So when you see the tubes with the dots in them and there's a gas, the question will be what kind of gas and what's going on. So that's like an important thing to keep in the back of your mind every time we look at these.
Yeah.
You know, getting back to the notion of connecting tubes internally, well, externally, but the in different ways, unconventionally. I think that's might be what Preston did. This is a Wilhelm Reich designed and built well, Preston called it a biosonde, right?
Okay. Yeah.
And this was actually a transmitter that was hanging down from weather balloons, Wilhelm Reich.
Yes. Yeah.
And when they came back, when the balloons emptied out and they came down, and if farmers found them in their field, they took them to the local county and they got paid $5 a pop for collecting these things. And they were just for transmitting weather information down to Earth. And Preston made this device called the biosonde. This is called a radiosonde.
Yep.
Right.
Yep.
And Preston, I'm sure, wired it internally, because I do believe there's miniature tubes in here. And the biosonde, which I have right over here, it just has a Radio Shack blue utility box. It's only about that big.
Yeah.
With a bunch of switches on it. But and you can connect a witness well to that device, and that will then broadcast with the electronics that are underneath this part.
Yep. Very cool.
Has anybody ever seen the biosonde?
I actually remember finding not the biosonde, but the radiosonde one time, and I took it to my dad, and he looked at it and he said, "Thank you," and he took it to wherever it needed to go or whatever. That was up in.
Well, I went up to Preston's place up in upstate New York. This was long after he was in, where was that? East Islip, right? But he moved upstate near Albany. Cairo, as a matter of fact, was the name of the little town. And he had evidently bought like all of these devices here that he could find, because in his backyard were plastic barrels full of these things.
Oh, wow.
Just all over the whole lawn. I wonder what master plan he had.
Yeah.
No
Do you
kidding.
know what my big question is? What happened to Preston's, like the space-time laboratory, all that gear, all that stuff he had in his yard? Do you know whatever happened to all that, Al?
Yeah. It was the the place was locked up for a while. And some friends of his locally were kind of keeping an eye on it, but eventually people broke in and took a lot of the, they destroyed his sound system.
Oh no. Wow.
And I went up there to get the stuff and found out that it was largely taken, and it was all cut up, and wires were just cut.
Yeah.
And
Wow.
but so I did find bits and pieces, which I took, right, and then stored for a few years.
Yeah. Oh.
But that's the sad story, because he had another house actually on his property, other than the one he lived in.
Yeah.
Which was full of electronics.
Wow.
Like the kind of scenery you've seen before in that video.
Yeah, or like John Hutchison's got, basically, right?
But he had that sound room with his bed, which had a
it shook the bed.
His sound system, the head of the bed rested on a subwoofer that was coupled to the floor to vibrate.
Yep.
And then he was surrounded by 6 speakers.
6, eh?
And 6 vacuum tube amplifiers, and then that all went to a rack of equipment.
That's interesting. 6.
I am in the process of designing a new kind of version of this now. I'm at the stage of finalizing my decision of what drivers to use.
What are you thinking about actually for drivers? Just out of curiosity, 2 types.
I think I might do an electrostatic accessory to this system, but that's for another reason. Okay, they're going to be, I think, just little small full range drivers, possibly
full range
in a certain array.
Yeah,
with like a central high frequency driver.
That was one of the things he did, is certain geometries of the layouts of the speakers, and that, wasn't it?
Yeah, he called it pyramid of sound, and he laid out the front speakers. Like I said, I've told you guys before that the rear speakers were like headphone amps, right? Headphone drivers.
Yeah.
But the front speakers, he had many of these small, very cheap, full range drivers, basically, or they were just wide range drivers, really.
Yeah.
Because he did pop a few, tweeters on there too.
Yeah. Interesting. Wow.
So I'm kind of like deciding what to do there.
Al, do you know what LEAP and LMS is? Loudspeaker measuring system and loudspeaker enclosure analysis program. I have both of them.
Oh my God.
Yeah.
Is this the one they're being used now a lot to measure?
It's state of the art. Yeah, it's absolutely.
The microphone goes around the speaker.
Mine is just a calibrated microphone with a super awesome oscillator. It was the whole setup was about 10 grand back in the 90s.
Oh, okay. Well, this is the one I'm talking about. It's like a brand new thing. That's just for total dispersion analysis and everything.
It's what all manufacturers use to design speakers.
What's it called again?
LEAP and LMS. So the LEAP part is the analysis part, and LMS is the actual measuring part. And and there are functions that LMS measures that are not in the teal small parameters. There's 4 of them, and they're dynamic functions. And then that gets transferred over. So it's the most accurate way of speaker designing that they ever conceived of, essentially.
I just thought I'd mention quickly who Preston Nichols was, because the author of I found a quick bio which looks okay. So I just said, because you were talking about Preston Nichols, and I was trying to. So the Montauk Project Experiments in Time by Preston B. Nichols and Peter Moon, published in 1992, is the first book in a series depicting time travel experiments at the Montauk Air Force Base at the eastern tip of Long Island. It is considered the progenitor of the Montauk Project.
Yep.
Right. Does anybody not have those books?
No, I don't have.
Oh,
Does anybody else? I have obviously all those books.
you should definitely check it out. I think I read the whole book in one sitting because I couldn't put it down.
But
Right.
it is rather light reading.
Yeah, yeah, and it's well written actually for what it is. It's quite well written because it's quite technical, but it's not. It's
Yeah,
well done.
There's five. I don't know what are there, five of them, I think, and some are more technical than the others.
I've only got the first one actually. I should get the rest of them too.
Yeah, there's one later on, one called Music and Time, I think.
Oh wow,
Yeah, I think
Now,
there's.
let me get it.
cool.
Yeah, I read them back when they came out in the 90s or whenever that was.
Yeah,
And it was great when you started talking about it and reading from it the other day. I was like, oh, wow, I should go back and read that
I
again.
have it pulled out.
yeah.
I had it right on the top of the stack here.
And both of you guys, you just who did you know from the Montauk Project? Both of you guys, can you just explain? Because we just spoke about Preston Nichols. I think you both knew him, didn't you?
Well, Al did, and
Oh,
Duncan,
yeah.
yeah, Duncan, we both knew.
Yeah,
Oh, you
Duncan
both
and
did. Okay.
mhm.
What about Al Bielek? Did you guys ever?
I met I met Al once when he first started coming out in the must have been around 93, 94. And all these guys were all putting this together. If you can find the recordings of them where they go into the Montauk base, they all meet up together. And
I've
they
got
kind
them.
of,
Yeah,
yeah, and they go around in the tour, and that was their process of putting this all together. It brought back all the memories.
yeah,
For Preston, it was to build the Delta T antenna, and they all realized they were part of this project and who they were and what they did. But it
yeah,
took a while of them getting together and going, "Well, you're like my half brother, and you were the guy that worked on the radios," and they kind of put the pieces of the story together like that, and they kind of live like a parallel lives because they were part of the MK Ultra process and the Phoenix project, and that's where they also mastered wiping the mind, right? And a lot of this
exactly.
is
Yep,
ET technology as well, right? So they
yep,
they would go to work essentially, and at the end of the day, they go, "You forget everything you've done here, blink," and then they go back home and do
yep,
their parallel lives where they lived in this uh, also that 20 and back stories and all those things that comes from that too, because
yeah,
you've noticed that 20-year time skip that's in there where in 1943 with USS Eldridge and
yeah,
then they could access what they called zero time, and it became part of their time travel experiments is shifting from this time stream that we're in, jump into zero time, and then you could pop back in.
yeah.
And there's these major cycles at 20 years, and that's how they were able to do the jump from 1943 to 1983.
Yeah.
They tried in 63, I think, but they didn't quite have the
The
technology right.
technology. Yeah, that's right. Yeah,
Yeah.
exactly. Yep. Yeah, it's super. It's
It's
such an
interesting
interesting.
how the movie, the Philadelphia Experiment, correlates with what happened. I think it was Al Bielek who said he when he was watching that movie one night, and it brought back all of the memories.
Yeah.
Wow.
So I'm wondering, like, who knew this and put that movie out so accurately, so to speak.
Yeah, exactly. Yeah. And I think there's in the last little while, at least I've found lots and lots of stuff from the Montauk Project and the Philadelphia Experiment. So on my channel, Technology Envoy, there's a playlist on there that has got like tons and tons of everything that you guys talk about. When they go to the base and they're filming and they're showing all the different rooms and all that stuff. That's all on there. Maybe we'll go through some of that in later ones here because this is all pretty interesting stuff. And you guys have had hands on because you're both at Montauk. So when you guys were on the bus together, who was in the bus with you?
There was a
The
interesting crowd.
the magic bus.
The magic bus.
Yeah.
Well,
I
think
found the
Roger-
pictures
Roger-
actually. I was looking.
Cool.
I've been looking for all these hard drives and stuff like that. Eventually, I asked Roger, and
Yeah, I think Roger has those
he found a
pictures.
few of them. Yeah, he sent them to me, so I have them here. If you want to see some of that
Oh,
stuff.
you got to show him.
Yeah.
Yeah, yeah.
The story is at one point, this was later years, because I got into all this stuff at an early age and always had a lot of questions. And for some reason, this whole story kind of resonated with me. So I said to Roger, "Why don't we do a tour out there?" And Roger, he organizes all these conferences and tours we do and stuff.
Yeah.
And so he puts it all together and he says, "Yeah, I found a Merry Prankster's bus, this psychedelic school bus." Uh,
That was
and
a
we could,
trip out there.
yeah, and we take this out to the thing. Now, that was the same year that the Merry Pranksters, I think Ken Casey's son, restored the bus further. And I don't know if you know that whole story, the electric Kool-Aid acid test and all this stuff. That's kind of a side
Wow.
story to all this, but
Wow.
they had restored that bus that they originally went with the 60s. And that same year, they were touring from San Francisco to New York because that's what the Merry
Oh, wow.
Pranksters did
Okay.
originally, right?
Yeah.
Yeah.
So it went from Haight-Ashbury to Montauk.
Yeah.
Wow.
Yeah.
And was it Duncan? Was it Duncan that was on the bus
Yeah,
with you?
Duncan Cameron came with us. So, yeah. And then
That
Duncan
is so
was our
cool.
guide, basically. And
Mm.
all the way there, as we're going along the trip, we'd stop the bus every now and then. Duncan all right, everybody get out. You got to feel the field. And we felt these fields, sort of like the Golden Dome concept, because Montauk has this field radiating around it. And we go out in the field, literally in a farmer's field, and you get everybody out there and you go, now walk from there to there and tell me what you feel. And everybody is like kind of sensing like this, and you could feel this energetic, field, and it
And
kind
so
of got darker and darker as we.
yeah.
Wow.
Yeah, when it got darker and darker, that's when the white utility vehicles started showing up, right?
Oh yeah.
Oh,
But
yeah.
no, the first one, Al, we pull up in the parking lot, this bus, right? And the bus is filled with beanbag chairs, and it's just this real casual thing. There was a bar, and we had food and snacks. And so it took a couple hours to get out there. We get out there and we stop in the parking lot, and we're just having some lunch before we go out and explore the area. And this is at Camp Hero, which is the tip of Long Island in near the town of Montauk, right?
Yeah.
This car, this Toyota Corolla, comes whipping up around the corner, and then we're the only people in the parking lot. We're the only people there. There's nothing, right? And all of a sudden, this car comes out in the parking lot and starts doing donuts behind the bus, and they're just peeling out, spinning around and around. Everybody's looking, what the heck's going on? Then the car stops in the middle of the parking lot, and these two guys get out with cameras with telephoto lenses like this long on it, and they start walking around the bus, and they're going, and they're taking pictures in
Whoa.
360 degrees around the bus,
Holy.
jump back in their car, do another donut, spin out, and take off down the road.
Security guys, obviously, or whatever.
But they looked like,
Spooks.
yeah, and they were driving a Toyota, just
This
this
is the most
weird car.
most action they've had in years.
Yeah,
Yeah.
exactly.
They were
Yeah.
fucking thrilled
Yeah.
you were
And the white vans came later, yeah.
Holy cow.
Yeah,
Wow.
it was funny. So this being an abandoned military base, well, there's still people there. And this was 2015, I think it was.
Okay.
So
Yeah.
when those guys started going there, it was abandoned, in the 90s.
Yeah.
But they were finding evidence that there was still stuff there. There was new power systems put in. There was
Yep.
coax going up to the big
Antenna.
antenna,
Yep.
and new power systems and phone lines, and a lot of stuff was underground.
Yeah.
And
Yeah.
when they were there, they got into the underground bunkers. They were still doors wide open. Nobody's there. When we went, they had put a cement wall over top of the bunkers. So,
Okay. So you couldn't get in there. Yeah, because there is a video, again on my channel on the playlist there where they walk around and they show, yeah, all the underground and a whole
yeah,
bunch of really cool things. Well, that's an awesome story, you guys. Let's keep going with the
yeah,
slides because we got a whole bunch of them here
we have
today.
to get those pictures, Paul. Okay.
yeah.
Yeah, we want to
I
see
know.
those. Definitely. So yeah, so here's another circuit. I picked this one out because it's voltage regulators and stuff, and this is stuff that I know, so that's why I picked it out. There's the 0A2 reference tubes that are like voltage references, basically. Um, there's the 12AX7 again. 6AS7G is a really common twin power triode, not a super large one, but those are quite common. I believe that this is a shunt regulator setup. I think they've got a regulator amp there.
You might say at the
Right.
bottom.
Do you know the gas on those dots?
That's a good question, actually.
Yeah.
No, I don't actually. And there's an OB or 0B2 there. And there's
And
one there.
they are diodes. They're meant to take a big pulse, right?
Well, these are actually meant as voltage references. So the reason they've got the OA or 0A2 and the 0B2 combined there in series is because they needed a specific voltage. So and they had to combine the two to get that voltage basically. So this is basically a power supply stuff. This is how they clean up the AC, so to speak, into DC so that they can feed it into the amplifier stages basically. And
So those gas tubes, what is their purpose to take a pulse? Do emit a pulse?
a voltage regulator, these don't quite operate like that, I don't think. No. No,
What do they? What kind of behavior?
they just provide a constant voltage. Let's say they want 70 volts DC. Then they would combine those two tubes in series to create that voltage as a reference point, and they just use it in the circuit essentially. It's all power supply stuff. All it's doing is smoothing the AC into a nice flat DC, basically.
Yeah, and if you look up the specs when it has a dot, it'll tell you what the gas is that's in it.
Yeah, and I actually have we can maybe next time we do because we're gonna have
I'd like
keep
to know what
bringing
these
stuff.
gases are too. I think it's very important.
Yep.
And not to mention, the question is, what's their purpose? Is that voltage supply? Are they acting like a capacitor? They're not meant to conduct?
They're usually rectifiers, usually they convert the AC to DC.
Yeah.
But
yeah,
here it looks like
it's a rectifier. That would kind of make sense, but that means we are doing a pulse in one direction.
Yeah. These operate the same as the Zener diode does. The Zener diode is something that's solid state that will give you a reference voltage, and this is just the tubed way of doing that essentially. But we will check into that. So let's keep going. But we'll definitely check into those gases because that's a really great question.
Can you stop right there?
Yeah.
I just saw something that said negative voltage.
Oh yeah, yep. Probably for biasing, right?
Regulated negative volt 300 volt circuit.
Yeah, here it is. Yeah. Negative output voltage of minus 105. Because I'm thinking, this might have some correlations with Obolensky's configuration of negative leading energy.
Oh yeah.
And a positive ground. In order to get the what is I've got a mental blank.
I think you're talking about biasing. You're biasing
inside a capacitor.
Okay.
Anyway, I'll think of it in a second.
Yeah.
It's what happens inside a capacitor.
Because when you speak of the negative voltage, when we set up a power triode to operate, we actually have to bias the tube to turn it on to make it work. And how we do that is with the negative voltage. That's something that, and we'll go into that a little bit more. We'll dive into how an 845 works, power triode works at some point here, and go, yeah. But yeah, this is all power supply stuff, and that's the reason why I pulled it out, is because this is the stuff that I know. Some of the other circuits in here these are way beyond me. But let's keep going, Brandon, because there's a lot of these slides, and we also want to go through Pavel's information.
There we go.
Yeah, this is the whole setup right here.
Right.
Right. So maybe maybe bring it out so we can see the whole
Oh.
thing at the same.
And
I just remembered what I was going to.
Preston
Yeah.
had one of those racks. Yeah.
Displacement current was the term I
Displacement
was.
current. Yeah.
Oh,
That's
okay.
what I'm trying to remember. I'm
Yep.
sorry.
Yep. The bottom part is power supply stuff. So that one circuit that we were just looking at are those very bottom ones.
Yeah.
And then there is a description as to what all these things are. But like I said, it's not just one box of electronics. It's a whole wall full. And all of these are full of tubes. There's 420 tubes in this setup right here. Those as well
So, you
too,
know,
right?
we froze for a moment. We've come back now. So Zoom is not responding. It's saying blah blah blah. Okay, I'll just stop that. Can you hear me?
Yeah.
Oh yeah, we can hear you.
Okay. So it froze for about a few seconds and then it came back.
You know,
Yep.
don't forget that this is a distant early warning system radar installation. So it's going to have all kinds of stuff like this as a cover story, if nothing else. But
Yeah.
I think it's all been utilized for another purpose, because Preston said that the big 300-foot oval shaped antenna that you see,
Mm-hmm.
he said that the horn, not the
Feed
it's
horn?
called the horn, the emitter that faces into the dish,
Yep.
Yeah.
and
Feed
it
horn.
reflects off the dish.
Yep.
That's the horn.
Yeah.
Okay. So he said that is what they used to broadcast a psychoactive signal. And of course, what comes out of the horn, instead of bouncing off the reflector, it goes right through, because it's a longitudinal function.
Okay.
And so that's how they were able to point it toward the town of Montauk and
Yep.
to see what effects it would have on people.
And animals and stuff. I know that animals
Mhm.
are really sensitive to all that, especially, right? Yeah. So it is a really, really complicated setup. That's for sure. There's no question about it.
Mhm.
I don't think I've ever seen a receiver setup more complicated than this
Right.
one,
No.
actually, to be
Mhm.
honest with you. Yeah, that manual is insane. It's 950 pages, right? And I went through most all of it, just kind of looking for stuff that was interesting. So I think maybe the next one, Brandon, might show
Not done. Okay, yeah, okay.
Yeah, that was an interesting. While you look up in Preston's sound room, he at one point he filled up that room with receivers, right?
yeah, you can
all
see
all
them.
tuned to his specification, to his sense of feeling, I guess. And
Yeah.
when you walked in the room before anything was even turned on, you felt something really interesting happening there.
Oh, wow. Cool. So this basically shows what all the, like I was
Right.
saying, across the bottom, there's the power supplies.
Yeah.
And, and see, there's multiples of certain units, like the
A
keyer.
lot of amps.
Yeah, a lot of amps, DC converter or amplifier converter, control panel, amplifier detector, radio frequency amplifiers as well, filter assemblies. So that'll be like a crossover in a speaker kind of setup, but way more complicated. Frequency converters. It's insane, actually.
It's all in the Monton book. Is that right, Eddie? In the Monton book.
No, this is not. This is
Well, here's something else you guys should take advantage of. You should all join the United States Psychotronics Association.
Yeah.
It's very cheap to do so.
okay.
And you have access to all of their
All that
tapes,
stuff. Yeah.
all the
Oh,
greats,
cool.
including Moray King.
Yeah, I was just about to
And
say
Tom
that. He's
Bearden.
part of it. Yeah.
And just to name a few of, all of them were there.
Yep.
But all of our friends for decades, right?
Yeah.
Yep.
It's
And
like the
Preston, the first one that I went to was in 1986. And the big thing for me at that year was Preston Nichols' presentation. And it was entitled The Geometry of Vacuum Tubes.
Oh, wow.
And in it, the second half of that tape is a demonstration of the mind amplifier.
No way.
With Duncan as the psychic, and he was projecting images to the audience. And then we asked a few people in the audience, what their sensations were. and
Yeah.
they picked up on what he was projecting. Interestingly,
Wow, that's so cool. And that all that stuff is available on to this organization if we join it, basically, is what you're saying?
yeah, you have access to all the tapes that were ever recorded, going back to the '70s, mid '70s.
Yeah.
Very cool. We'll definitely be checking into that. Thank you for that. Wow.
The best deal ever.
Yeah.
Yeah. So some of these are just pictures of what some of the electronics look like inside.
Nice.
So this one, I think I chose it because it's got the oscillators in it. There's also a harmonic generator, a 6AG5, which I've never seen one of those before, but harmonic generator. 6AU6, I've got some of those. There's the 6AL5, which is the diode. So it's being used as a rectifier there.
Yeah.
Yeah, lots and lots of electronics. Every single one of those boxes would have stuff like this in it, just full. And this is the clean side of it. If you were to flip this over and see the wiring side, now you really see how complicated all of this stuff is, basically, right? Yeah, very cool.
Okay, so
Yeah, we can just keep going, Brandon.
Right.
This one is the power supply. So we were looking at some of the power supply schematics. This is actually showing us, there's the 6AS7G tubes. They're probably used as shunt regulators. There's a 5R4GY, that's a regulator, a rectifier tube, sorry. Yeah, rectifier. There's a voltage, OB2 voltage reference again, the one that's got the gas in it. 12AX7 is used as an amplifier or regulator amplifier in this case. And then
big transformers.
Yep, big transformers. Exactly. And the transformers basically take the 120 volts and change it to whatever voltage they want, but it's still AC. A transformer can't change it to DC. They need all of this circuitry to basically change it to a nice, flat, smooth DC. So it's usable in some of the next stuff that we're going to look at, essentially. Yeah.
All of these tubes are used in audio. These are all audio related tubes.
Yeah. Now look at this is where it's getting a little bit more crazy, right? And again, these are just random things that I pulled out of here. The harmonic generator, you can see, what did you say at the bottom?
whoopsie.
6AH6, I think. Those look like a pentode or something, maybe. There's one, two.
It's
Yeah,
highly likely. Yeah.
Yeah, those are pentodes. Yeah, it just goes to show the complexity of everything, essentially. I'm not even sure what circuit this was. What does it say at the top there, Brendan?
Is this related to the Montauk project, Eddie?
This is the electronics of the Montauk project. Everything that we're doing today is that wall of equipment that we just saw. This is the schematic, or one part of the schematic for one single box. And I don't know how many there were there. There was 30 or 40 of them,
And the crazy thing is, a lot of that stuff was still in there. Even when we were there, there was still electronic gear. You could walk around and see this stuff. Some of it, a lot of it was vandalized, damaged, and pulled out of there. But some things were too big, like a lot of the power supplies and the big transformers and that. They're all still there.
Man, we should go get some of that stuff.
Yeah. Well, Preston said that he actually climbed up on the tower of the dish at the top. So you're up 8 stories on the concrete building, and that Sage radar dish weighed who knows how many tons, right?
Oh yeah.
So this building was built like a tank, and he climbed up the tower on that and got some of the wiring and the antennas and stuff that were on the back, because they also had another antenna array behind the actual dish.
Oh wow!
But I think Preston salvaged some stuff out of there too.
That is cool. That is so cool to know. Yeah, I mean, I would have been in there trying to get everything I can out of there.
Yeah, same.
Yeah. And Preston would take us over to this one location where it looked like a blowtorch had cut a bunch of wires
Yeah,
across. You
I
saw
saw
those?
that on the video. I saw it on a video. That's where he cut. It was what the heck was it? It was
Duncan had to shut it down. So they cut in a few instances. Even when they created Junior, they had to cut the power too. So several times the system would run away because it was so much power and everything. And they'd go to release the master switches, but they were like electromagnetically held in place. And with all your might, you couldn't pull the power apart on this thing to flip the main switches off.
yeah.
So at certain points along the way, they had to just take blowtorches and axes to the main power lines, and just sparks would be flying everywhere, and
Yeah.
cut the power literally.
Yeah, they cut through stuff. And I remember him saying that they cut a bunch of power and it still didn't shut off. And then there was one thing that they went to that finally, and their blowtorch marks are there because it's in the videos, right?
Yeah.
And I can't
Mhm.
remember what it was though. What they called it. I can't remember. Yeah, but very, very interesting.
The AI is going to need that to
Yeah.
stay on to keep the humans from shutting it off.
Yeah.
Mhm. Right.
Yeah.
So good find.
Right. They're going to lose that little bit of information.
Yeah. Yeah, you can just keep going, Brandon. I just wanted to kind of show the complexity of everything, right? Here's another like crazy. Look at this. Those are diodes again. They're doing some kind of cancellation harmonic stuff, I think, with these diodes.
There'd be a lot of filtering and a lot of
Yeah.
Was
Wow.
was Tesla working on this along with Townsend Brown?
Tesla designed this.
All right, right.
Yeah. T.T. Brown, he was part of it too, but this is Nikola Tesla's work right here, you guys. That's the other reason we want to look at it. Yeah, he designed the electronics. Definitely. Yeah. In fact, almost all vacuum tube stuff, except for some of the earlier stuff, is really comes up to RCA. RCA was the largest vacuum tube manufacturer in the world, and he was the engineering genius that designed all of it.
What gave them the idea of time travel or teleportation in electronics? Did they just come across it by accident in experiments and then developed it?
they realized
Did they
that
know
they
about
could.
it in the first place?
Yeah, picture it like a big remote viewing, is kind of the way you can look at it today. When they were able to figure out how to collect the thoughts, and then they were able to figure out how to project them, they could physically manifest things and stuff. So eventually they realized that it had to do with time, and a lot of it had to do with time. So then they started saying, all right, get in the chair and look back and look forward. And they were able to go back hundreds of thousands of years in time and forward, who
And
knows
forward.
how. I remember there was a wall. There was something about that horse, and they kept hitting a wall. And I think it was right around now. It was like 2026 or something like that, that they said there was a wall that they had to get over.
Oh, interesting.
So there's some relevance to this time period, and it's interesting that all this comes back up again. But
Well, exactly. We're doing it right now. Like,
Like
it's insane.
Like electronics can be a portal for consciousness in a way. Sort of like
Well,
Oh yeah. That's the nature of our work.
This
This is
this can be
forbidden.
considered a mind amplifier, like you were saying, essentially, right? So it's actually taking your conscious thoughts,
right.
putting them in a computer, because that was a big part of it, and then working with that in different frequency modes and different modulations, because I think there was 4 different modulations.
Essentially the person would sit in the chair, and Duncan was one of those people. The chair was at the center of a delta T antenna that was basically like 2 pyramids, like an octahedron, essentially like that.
Yep.
And the chair is in the center, so you have 4 loops. So you got an X, Y, and a Z axis of wire. And so this amplifier, or this receiver here, was what they would do is take all the subtle vibrations from those XYZ accesses around the person in the chair, and those signals were coming through this system to interpolate into data that they could put into the computer as the interface.
Yep.
Also,
So
it's
that was the receiving side of it, and then they could project it. They'd put it back through the big amplifiers, those amplitrons, and that
Ampletrons, yeah.
into the Sage radar dish, and send that the same signals that they got outwards. And
Yep.
yeah,
you've
so it
got
was
electrical signals in biological beings like the brain, the nerve, the blood,
yeah,
and the nervous
Mhm.
system. There's all electrical signals there as well, isn't it? So
yeah,
Yep. That's
oh
what
yeah,
that's what they're using essentially. Yeah.
yeah.
This
You
Exactly.
guys
remind
had
this
well,
reminds me of Forbidden Planet,
I,
doesn't it?
Maury, I was just going to say that. I was going to ask you.
Well,
You
so
beat me by a
many,
half a
No,
second.
really,
yeah,
really
Yeah,
be
yeah.
careful
yeah.
what
Well,
you
even
wish
that
for.
series Stranger Things apparently is all based on stuff
It
that happened out there too.
yeah,
So
because the
isn't that
person that,
sci-fi?
yeah, because the person that the girl that does it, there's actually videos about her talking about all this stuff too, and how that show was mimicking Montauk for the most part, right? Yeah.
Yeah.
Yeah, it's really, really cool. Yeah, just keep going, Brandon. There's lots and lots of these. We'll just keep talking and looking at stuff. So it's getting more and more complicated. Look at what's going on with these circuits, right?
So, how many people have seen the Forbidden Planet? Has everybody?
Forbidden
No.
Planet is
No.
what's
If you haven't seen Forbidden Planet, you got to do it right now. See you
Okay.
later.
All right.
See you next week.
it's not Planet of the Apes. It's something. No?
No, no, no.
I was thinking
What's
Forbidden Planet.
what's that?
No.
Forbidden Planet.
Well, I'm sure Planet of the Apes had part of the story in it too, right?
Oh,
that
and the
was
Time Machine, of course. That's another interesting one. But
Oh,
but yeah, Forbidden Planet has all of this technology. That's what the Krell technology was all about.
What's the
okay.
year?
You know,
was
the Junior was the monster from the id
Okay.
in Forbidden Planet, right?
Yeah.
Oh,
what
okay.
year? What year was
Check
the
it out.
movie?
So the story of Junior, what happened when those guys started to catch on that, hey, we're part of this weird mind control project, and maybe some of the things we're doing aren't so good. They started to feel bad. They felt really guilty about it.
Yeah.
So they came up with this idea to kibosh the project.
Yeah.
So Duncan said, well, we'll manifest like a monster, and we'll let this monster loose to start ripping all the base apart and rip all the equipment apart. So he thought about it while he was in the chair during one of the experiments, and sure enough, this Bigfoot type creature shows up around the base and just starts ransacking the place and crashing down the buildings and ripping stuff apart.
Yeah.
It was part of their sabotage thing, so they named him Junior.
Yeah, I remember that part. And that's the other thing. At Montauk, they were able to manifest things because I made a little short YouTube clip that's on my channel about them manifesting a can of Budweiser on
Beer.
the commander's desk,
Yeah.
the base commander's desk, right? And when he drank it, he said it tasted better than normal Bud,
Right.
right?
Yeah.
So interesting.
Plausible deniability.
Exactly, right? And
this bud's for you.
yeah, exactly. So yeah. Okay, so this is showing us more of some of the functions, and again, this is probably just one piece of equipment, I think, or no, or is this got no? This looks like
Area
it
of operation.
might have.
Overall simplification, functional block diagram.
Yes.
Overall simplified.
So you've got antenna input. Um, what is an AGC output? What is that?
Automatic gain control.
Yeah.
Okay. You've got an audio output, keyed DC tone output, teletype. Yeah, because it was teletypes that they had back then. You've got different frequency oscillators. You know what this reminds me of is John Hutchison's chart. You know, he's got multiple oscillators, and obviously there's a parallel here. 50 kilohertz IF amplifier, so infrared frequency amplifier. Second
The
converter.
IF stage is where they combine two heterodyning your main carrier wave, like in all the radios and stuff, they use like 500 kilohertz and that, and then you mix the signal, and it's a way of cleaning up your signal as you receive.
Yep. Cool. Very cool. Crystal calibrator. Yeah, harmonic oscillator. That, for some reason, I needed to look at this more closely. One thing I will say, I don't know if I told you guys that Dr. James Schwartz, who has working free energy, it was actually the very first show that I did on my channel. He has the frequency generator from the Philadelphia experiment. So it's going to be similar to what this is talking about right here, this oscillator.
Right. Interesting.
Yeah, 200 kilohertz oscillator and harmonic generator. 6AU 6 tube inductors, plate voltage, screens. Wow. Screens because it's a pentode. 47 microfarads. Wow.
A
Tunable.
microfarad. So
Microfarad.
Yeah, MMF. They used to use that originally before they used picofarads and that.
Yep.
all right. So
Those are tunable capacitors. That's interesting.
Yeah.
Yep.
All
Yep.
those, yeah, the ones you saw in that other picture where there's plates. Well, actually, here's one. Those are variable capacitors.
Oh
that
yeah,
use
look at
tuning
that.
plates. This is
Yeah,
a really
yeah.
big one. Yeah.
That's a huge one.
And you can see as those plates sandwich together, it's basically using air as your dielectric in the
Yeah.
Yep.
capacitor, and so you can tune it just
that's
by
in the
adjusting
radios.
the proximity of the plates to each other. Yeah.
That's super cool. It's funny that you have that right there too.
Very productive.
I got everything right here.
That's awesome.
In the 20th century, they're very productive. There's a lot going on, wasn't there, in the 20th century?
Yeah,
Yes,
and
Einstein,
they don't make that stuff anymore. You can't.
Exactly.
Brown, going from buggies to airplanes just in a few decades.
Yeah, there was an exponential curve that we've gone through all of this.
Yeah. Yeah, and we really are looking at probably the most sophisticated electronics that you could ever conceive of right now, because even the stuff that my dad did for navigation at the airports and that wasn't this complicated, because I remember seeing it. I used to go to work with him all the time back in the day. So this is the actual from the book. This is sort of the setup, and a lot of the electronics that we were looking at are these little boxes, basically.
Yeah.
Yeah. Does one of you guys want to describe kind of what's going on here?
I can't quite read it, but basically you'd have your antenna coming in, your mixer, your IF filters where you create a basic signal that you heterodyne your other incoming signal from the antenna in it. And it kind of amplifies it, and then you split it apart at a later on point. And then they're going into amplifiers, mixers, so they're mixing a lot of different waveforms on what they receive.
Yeah.
Then the discriminators kind of takes them apart, and so by mixing and taking apart, you're basically making a cleaner signal.
Okay.
Kind of like cleaning up your because the signals you're receiving are very, very faint and very, very weak, and there's a lot of noise. There's a lot of background noise, so you
Yep.
have to be able to bring that signal in and then use those IF kind of filtering to cut out the noise, basically. Yeah.
Yep.
IF, what does IF stand for?
Yeah.
Infrared.
No, it's not
No.
infrared. I don't recall, but it's a common thing in every.
Type of noise.
Intermediate for the eye,
Yeah,
and frequency for
filter.
the F, intermediate frequency. Is that IF? Anybody can jump online and get
Yeah,
the,
I'm not sure.
Yeah, it's
somebody
a common
jump
thing
online and get the
in every
what it
receiver.
stands for.
It's just not coming to me right now.
I can look it up if you like. Quickly.
Yeah, look
Yeah.
it up. Look
Yeah.
it up, but keep the show going and then
Yeah.
come back in.
You can see. Oh, maybe put the screen back up there.
See. So IF
Yeah,
in electric
Radio.
Electronics.
The function, yeah.
in radio receiver.
in radio receiver receiver.
Intermediate frequency.
Frequency, there
That's
you
where they're
go.
mixing another frequency on the waves that you're
Yeah.
receiving. Yeah.
Perfect. There we go. I was just,
Heterodyny.
yeah, I was just noticing the 25 kilowatt linear amplifier in the carrier processor. That's a pretty big amplifier.
Yeah.
That's a huge amplifier,
Huge.
actually huge. Yeah. Is that because I know that they used a big white noise amplifier? Maybe that's what that is. I don't see it anywhere else. AF amps, filters, discriminator, the low. Yeah, and you can see how they're 2 to 30 megahertz.
Yeah. Then the detector unit at that end, you have the upper sideband and the lower sideband. So it splits out. You have your main frequency that things are riding on, and then you have the upper and lower sidebands.
Yeah,
How ham radios basically work. Yeah.
yeah. 29. Those are probably filters mix.
Does AF stand for audio frequency?
Yeah, yeah.
Yeah, USB is upper sideband, LSB is lower sideband. And then the
So-
combination of the two and the product detector. And then you see how that goes out to the 25 kilohertz that has a feedback loop that comes
Yeah,
back
I
to
was
the
just-
carrier
I was
processor.
just seeing
That's
that.
another way to clean up the signals. Like you see that in audio amplifiers too with negative
Yeah.
feedback or whatever.
Yeah, exactly. They don't sound good when you do it that way, but yeah,
Yeah.
exactly. Yeah, negative feedback.
Well, that's a big battle in the audio world, right? I mean, if it's done right, I think you can. You look at it on a spectrum analyzer, and you get these even harmonics that come out of it, and it's all about the tonality of the sound
Yep,
that you're looking for.
yep. My 845 monoblocks, when I first got them, had negative feedback in them.
Yeah,
I tore that all out of there, and it
Well,
sounds way
it has
better
to be. Yeah, it
without
has to
it.
be very accurate. The negative feedback, because it's the transient component of the signal that gets screwed up with negative feedback.
Yeah, I hear it in the voices when I listen to voices.
right.
That's where I hear, and that's when I test. I always listen. I haven't had a negative feedback amplifier for about 2 decades. Ever since I
Oh.
figured out.
You can clearly notice it when it's variable. You could turn it
Yeah.
off on some audio
Yeah.
amp designs to
Yep.
sound so much better when it's off.
Yeah,
I don't know
Carry
if you-
Audio had a lot of those. Yeah.
Yeah. Do you watch many of the other videos out there on YouTube, people building amplifiers and stuff? Do you know David Baird? If you look at some of his videos, he's an old timer that's, basically does audio amps, a lot of RF stuff and that.
Baird, David Baird,
Yeah, Baird, I think. Baird.
BAI.
I think I've heard of him
Oh,
before.
Yeah.
Okay.
I forget the name of his amp. It's down in the States somewhere, but
What was he? What was it?
So
Audio
what he
designer,
does,
you mean?
he's showing negative feedback and how to do it properly, and he does everything, analyzing everything. He's got a spectrum analyzer and stuff, and
Yeah.
shows how the harmonics, and it all depends on the tubes you're using and your circuits and all that too.
Yeah, how linear they are, and yeah.
Yeah, but I think it's all in those, looking at those second, third, fourth, fifth, sixth order harmonics. That's what we're perceiving as our the sound that we like about tubes. That real analog sound is all those harmonics, and if you get them mixed just right, yeah, that's the magic.
So here's your noise amp, 100 kilowatt.
Oh,
Yep.
okay.
Yeah, exactly. Yeah, this is like a bigger block diagram of everything. You can see the delta T antenna, the 100K noise amp, the computer system, the chair, and then those are transformers to.
Yeah,
Right.
that delta T, that's the antenna out to the delta T.
I think
Right,
if
notice the
change.
direction.
Change in
Yeah.
time.
The noise
Essentially,
amp is
that's what-
going into the antenna.
Yeah, it is, isn't it?
Right, so they're projecting. No, okay, okay, this is great. All right, I haven't got a chance to go through this yet, but there you go. So they're putting the white noise on transmitting the antenna at the same time. So it's basically mixing the signal with white noise and putting a ton of power, 100 kilowatts of power of white noise into the antenna,
Yeah.
along with the very subtle signals that came from the person in the Montauk chair,
Yeah.
amplified, and mixing those two.
If
As
they're
a
traveling
wall
in
of
time, if
of
they're
sound.
traveling in time, then time must
And
be
don't-
some
don't-
kind of physical construct. Time must be some sort of like a bit like a physical construct. Does that make
That's why they called it the Delta T antenna. Basically means change in time.
Exactly.
So
Yep.
remember last week I described the mind amplifier, the rear pickups,
Same principle.
and how they had a white noise source that was mixed in
Yeah.
Okay. Yeah.
at the point where the signals were being picked up by the headphone drivers.
Those
So this is the
headphone
same
drivers,
thing here.
were they actual like headphones, or were they just he used those drivers?
They're
Like how
little-
many were they? How many were there? Were there two, or were there multiples of them?
Oh no, there were several.
Okay.
You
Okay.
couldn't see. They were inside. They were inside plywood.
Wow.
You couldn't see anything. You could hear the white noise through all the wood and everything,
Wow.
but it was completely sealed.
Interesting. That's
Mm.
really interesting. Wow.
Yeah, yeah.
Do they
Um,
know? What's the antenna look like?
It's
It's,
huge.
it's an octahedron that
Yeah.
Delta T is.
Two
the
pyramids,
Delta T
face to
antenna.
face.
Yeah.
So yeah, two pyramids, bottom to bottom.
Would it be like a Giza pyramid geometry?
Yeah,
Probably.
pretty close.
Yeah, very close.
And the edges were the conductors.
Yeah, each of the vertices were axes. So this vertice would be like your x-axis, and then this would be your y and a z, right? So you have this three-dimensional plane. And the thing about this later evolved into the HARP project too. The HARP project ended up being a whole field array of these Delta T antennas.
Yeah.
And because you can steer when you're using them as a transmitting antenna, so they used them both as a receiver. So it was a receiver around the Montauk chair. But then when they learned to transmit with them, like Preston was doing, they set up that big array in Alaska. And what you can do is by varying the X, Y, Z and axis, you get a directional beam.
You can steer them,
Yeah, you steer them. So you're conjugating now your phases in a linear plane of multiple Delta T antennas. Then you create these beams that can focus up at the upper atmosphere. And then they're creating a lens in the upper atmosphere that can let cosmic radiation come in. And
Are they using interferometry to do that?
Basically, yeah. Yeah.
Oh yeah, it's like what do you call it? The radar. What do they call it when you
over the
focus
horizon radar?
No.
Phased array.
Phased array.
Phased array.
It's
radar.
a phased array. They do it with cell phone towers too. It's a phased array. Basically, you're steering your beams to create hot spots and concentrate that energy when you're transmitting.
I have a question on the antenna. You mentioned it's a tetrahedron shape. There's two of them. One edge of the tetrahedron, how are they connected?
Well, I think the noise circuit, the noise channel is the wires that go around the base of the pyramids.
Okay.
Right. I wanted to know, is the edge a conductor? Do we have the edges connected to each other so it's all a single tetrahedron conductor?
No.
Are the edges separated from each other connectivity?
Yeah, they're all separated.
So every edge of this tetrahedron can be driven independently.
Yeah, they're basically
is that the right?
And they're not tetrahedrons. They got four sides. So there's four, and then one big flat side on the bottom.
They're basically identical squares at different angles.
Squares. Yeah, if you look at it.
Right, because I can envision, because I don't know what section is conducting. I could even envision like each edge is a dipole and you're driving it like a dipole.
They're loops, yeah. They're each
They're
edge,
loops,
each
yeah.
vertice all the way around is a loop. So there's
It's a loop,
multiple
yeah.
turns in that loop. So there's
40
three
turns.
loops.
I think
Yeah,
there was
look,
40 turns with the one that he built
Yeah.
at home. Preston
Yeah.
built at home. Yeah.
yeah. So three
Vertice
loops.
is a loop. Okay, any picture at all to show
I
that?
wish I had some.
I don't.
You know what, Moray, again in my channel, we could go to it actually. If Brendan,
Well,
do
you can see it fairly well in that video.
Okay, let's have a look. So go to your channel, Eddie. Yeah.
Isn't there a picture in the book too?
Of the
yeah,
antenna.
but those screenshots, I've only got just those. But in the videos here, if you go to my playlist,
I'll have to go on. I'll have to go on my laptop for the volume.
okay, if you go on the playlist, then I'll show you guys too where to look for all the Montauk stuff, because it's all in one spot. Philadelphia Experiment Montauk, and there's all kinds of videos there. The playlist, and then Montauk. Oh, there it is. It's the first one, Philadelphia Experiment in Montauk.
That what he had at that conference and what he worked on.
Look, here's the first one.
Yeah.
But like, to shut that off and go, let's look at all of them. Yeah.
He's a kook. Turn that off.
Yeah.
What do you want to do? Go for all of them?
Yeah, I just need to be able to see them. It's so small. I think that 221, that Preston modified the Sage radar. It might be on that one.
Old Montauk Air Force Base. Okay. They went out there. They masqueraded.
Wasn't it? I think it was the one that's labeled the tour.
Air Force personnel.
Okay.
Tour.
Yeah, it could be. There's so many of them on there. I don't know if we'll be able to find it exactly.
Eddie?
Go through it fast and let's just, because that's what we're looking for, the picture of the.
And they reactivated the old Sage radar because it transmitted on the same frequency range that Wilhelm Reich used for his orgone studies.
Mm-hmm. Right.
So it was decided to refurbish the old Sage transmitter. It was there, it was usable. So they got the Air Force personnel in and refurbished it. Then they contracted with the company BJM that I used to work for, and I went out, I started to modify it and,
what is BJM specifically?
It's a military industrial contract that we made radar jamming equipment. Okay.
So what's your background?
I'm essentially an electrical engineer. I have a BS degree.
Sorry, I'm trying to get it back. I'm trying to stop it now. Okay, so I'll go and do
Yeah.
that.
Yeah, it's not on this. It's not on this one. Let's look at a few more, but I think we'll have to maybe
Isn't it
find
at the
that
end
for
of
you
this?
later.
I think at the end of this, that's inside his space-time laboratories, and then they go outside.
Yeah, but this is just a short clip that I made of.
Okay.
Yeah.
Okay.
Yeah.
Well,
So-
I drew a picture. So
oh, there we go.
you see your octahedron there, if I can get it into place.
Yep.
Stop going.
Yeah, there you
Yeah.
go.
Okay.
There we
Now,
go.
okay. So yeah, that's the basic shape. If you were to look at it from the top down, you have three loops. One loop goes around this horizontal plane.
That's the white noise.
Yeah, and then
Okay.
the other two parts of this diamond around here are the other two loops. So if you're looking from the top down, it's like that. And so you got three loops in an XYZ configuration.
Yeah. And I'll find a picture for next time for you, Moray. Yeah. Cool.
Just
Okay.
looking at the conductivity, right? That was the question, because obviously, you do all this, and then the whole point was to emit it right out into the environment, right?
Yeah.
And then the shape of the antenna is very important. What is going to be the field, right? Obviously, it's
Yeah.
a near field effect that you're trying to do. Okay, I didn't want to distract this whole thing, but I thought, okay,
Yeah,
that's an important part.
It
and
is,
So we
yeah.
could
Yeah.
have
Yeah.
we should have a shape. Oh, and this is how you drive it. These are where the conductivity pieces are. Okay, I didn't mean to derail the.
Oh, no
Does
worries.
anybody understand how they transport? Does anybody understand the physics of how they move through time, or is it just Is it just that certain electronic equipment seems to do it, so they just go with it?
Wormholes. Everybody knows this.
Yeah.
Yeah, no, I think you might go a bit beyond that.
Spiraling. It's about spiraling the signal too, right? That's part of it. Yeah. But it is about opening up wormholes.
Yeah, we're so beyond our science here. Everything we're talking about. I mean, this is all in the alien realm. So
These have been these black projects for years. That's the whole thing about this stuff is now that everything's falling apart for the entire system. It's good because all this stuff is coming to the surface now, and everybody wants this disclosure and all this. And what you got to realize is that we've had all these technologies; they've just been kept secret for
exactly. Yep. They were in, especially the secret space programs. That's where a lot of this stuff comes out of, right?
Oh, there you go. Okay,
and
there's
it's beyond our standard science, like was taught in school. So this is well beyond.
It's all in the classified realm, is where it all is.
This is a perfect, block diagram of how those coils fit into that shape. And now they got the 4 coils there to show you the X, Y, and Z. Yeah.
And then those coils are actually wrapped into this double pyramid shape, essentially.
So at least we say coil here. There would be a standard cylinder type of coil. That's what comes to mind. But you could wrapping a coil that tapers on a pyramid form. I could picture that, right? You're wrapping the coil around. So the coil is the conductor, and the pyramid is just holding it in place. Right. To
the geometry,
the wrapping of it. So it's like you have a coil that's tapering, etc. Is that the idea?
It's a loop type coil. It's basically like a loop antenna in each of the directions.
Well, look at the Z coil, which is the white noise, right? Look where that goes around.
Yep.
The person. That will be the plane, the horizontal plane. Yeah.
Yeah.
It looks like it's bifilar. Looks like it's induction canceling too.
They
would show
another.
Yeah, I don't think it is, because they would actually.
They interact together like a bifilar would between the 3 of them, but they're not reversing on themselves.
Yeah. This is the silver bullet.
So they have multiple windings per coil, or one loop per coil. Multiple loops,
multiple loops. Yeah.
We're showing one for simplicity, but
right. And approximately how many wraps per coil?
Well, Preston had 40 at home, but that was the small version. The big version, I don't know.
So the ones that are connected are diametrically opposed. So, and then obviously the white noise coil is the separate in the middle. The oval. So that's pretty simple, actually.
Yeah. But I was just trying to get the geometry.
He actually said. Yeah, I remember now. I'm saying something about. So you got the 3 X, Y, and Z, and then the other. There was another coil that went around your head somewhere. Maybe they wore it in a headband, or it was part of the upper part of the pyramid, or something like that.
Wow. Interesting.
Did it affect their age when they traveled in time? Did it affect their age, or did they remain the same age?
It was like remote viewing.
Yeah, exactly. Rebecca talked a lot about it, and in her case, they sent her out. I do remember this. They sent her out a bunch of times to one specific spot where she wouldn't talk about what she saw, so they kept doing it over and over again, and they were torturing her, but they were actually killing her. They actually were killing her every time and then bringing her back just seconds before she left. So it's like a 20 and back kind of setup. Because she actually asked me, how did they do it? And that's when I went back and remote viewed what it was going on. And that's kind of what I came up with, essentially. I also do know that it's a spiraling that's very important with all of this, too. That the field needs to spiral. Yeah.
Well, that would naturally happen if you wrapped it on a tapered form.
Yeah, exactly. And I think that's the whole premise of the delta T part. The change in time is,
no, this is all about, quadrature. that they're all 90 degrees. They cross each other, right?
Yeah.
Mhm.
X, Y, and
Yes.
Z. Yeah.
So
That was
the
very
Mon-
important to Preston.
the Montauk chair is basically a bit like remote viewing. It's not actually traveling in time so much as remote viewing the future.
Yeah.
Right?
Correct. Yeah. Yeah, that's correct. Project Pegasus was where they actually walked through like a Stargate portal and went into a different time. And that was Andrew Basiago. That my father knew one of the physicists that worked on that project as well, too. But that is different. No, this was like remote viewing, exactly, where you are able to go back and forth and
A
look
bit
at
like
things.
aiding remote viewing, remote viewing the
But
future with the
but they
aiding
were
technology.
but I think they were able to record it too, right? Aren't there videos and stuff of some of the places that they went and whatnot, I believe? I think that was all part of the computer system that
Is
they had.
this connected to so there's a story of one of the prominent remote viewers who was taken to a chair, and it was just over the border into Canada.
Okay.
And then they asked him to project to everyone in that area that they would file their taxes the following year in a particular remote middle of nowhere post office.
Oh yeah.
And then they tracked, and then the following year, like 80% of the people in that district went to this middle of nowhere post office and filed their taxes there. I don't know, is there something to that? And is that this Montauk chair?
Well, it sounds
That's
like it could be similar.
kind
Yeah.
of thing they did. Yeah.
Yeah, exactly. Yeah. And there was thousands and thousands of people. They lost thousands and thousands of people before they actually could figure out how to get them back properly. Because Rebecca and I talked a lot about how all the people that they lost as well too. Um, yeah, so now we've got something really cool to show you. This is stuff that Pavel just sent us this morning.
Hmm.
And he has got a setup for measuring brain waves, essentially. And he's asked us to kind of have a look at everything. And one of the things that he said yesterday was, I think the voltage, he needs more gain, basically. So he needs a little bit more voltage out of the whole setup. But let's just kind of, there's a lot to this, so I don't know if we'll be able to read through all of it, but let's read through this one.
Is there some kind of helmet or sensors that you wear with this?
Yeah,
that's
you're gonna
coming
see that.
that's
Yeah, you're
in
gonna see that in a second here.
this one
Okay.
here. It's in this one here. Okay,
Yeah.
shall
So
we read it?
let's read that first.
Goal. Produce an affordable price around 2,000 KZ K
77 euros.
CZK, 77
Check around.
Tech dollars, yeah.
competition requiring a computer. Measuring alpha brainwaves allows you to optimize meditative breathing.
Sorry, could you stop for a second there? Sorry, Brandon. Pavel, is that you're saying that you want this to be $77 euro, but the competition requires a computer and it's like $1,920 euro, right?
Yes, another company that produce a very complicated system that needs computer and is very expensive.
Okay, cool. Yep.
My goal was to create this small equipment, and there is a connector to add these three sensors.
Yeah. Is that something that we can buy right now? Pavel, like if we wanted to buy one of those, can you supply one of those?
I don't understand.
Purchase it?
Purchase. He wants to purchase with money to buy.
Is that something that you have that we could?
Yes, it will be available, I think, very soon. I must finish this amplifier that I sent you the second. There is a description how can this very this is a very small signal that must be through amplifier increase that can be used in this box, that there is a fast Fourier transform that is necessary to detect frequency between 10 to 13 hertz. That is
Okay.
very important for alpha wave.
Okay. Okay, Brandon, you might as well carry on and
I have a
Measuring-
small JFET amplifier that'll work for you, Pavel. I can get that to you.
oh, there you go.
Yeah.
Measuring
Cool.
alpha brain waves allows you to optimize meditative breathing with meditation music and meditative images in order to reduce stress, thereby strengthening the immune system with greater resistance to diseases. It is enough to use 3 electrodes, usually 2 on the ears and a third on the forehead and the back of the head. Device must use a fast Fourier transform to monitor the signal with a frequency of 10 to 13 hertz. It will have a touch screen displaying the time course of brain signals and spectral analysis. It will be able to count the individual intervals when the brain produces alpha waves, i.e., the time when it rests and regenerates.
Wow, very cool.
Okay, so this was active electrode building guide. Important note, please do not contact me about active electrodes. You will get more help if you send an email to Open EEG mailing list. Also, check out Omlex if you Olimex if you are interested in buying a pre-assembled active electrode.
Okay.
This guide should help you to build active electrodes for the modular EEG as proposed by Jarek. I can't pronounce that. The active electrodes described here correspond to modified circuit diagram suggested by Jörg Hansman. This guide proposes a trade-off between building simplicity and signal quality. The guarding box has been omitted and replaced with silicon for encapsulation, because making robust and very small mini boxes is not simple at all. These are instructions for building 4 active electrodes, 2 channels. If you want to try another approach using batteries, give Joe Street's AGs a try. Please be warned that making AGs is not a simple task. I myself needed to make several prototypes to arrive at this design. Several people on the Open EEG list have reported problems with the electrodes described on this page, but I don't know why. They work perfectly for me. In a previous design, I tried a rectangular pin array, but it didn't work. Someone on the list pointed out that this can be due to the particular pin material. That's why this approach uses only silver wires.
Mhm.
Also, the thin pin arrays can hurt your skin if you use them for too long. Okay. Step 1. First of all, I decided to etch the boards myself because industrial etching is expensive and requires a careful final design. So this is actually my latest design so far, and it worked well. To start, download the active electrode template from this link. The template includes 40 active electrode patterns for etching. Do you want to place?
No,
where
I
they
just
can
is rather
access this doc-
arcane stuff. Yeah, let's move on.
Okay. Do you
Please
want to
just
place? I was asking Pavel, is there a place where we want people to access this or whatever? Anyway,
For me, it's very important this second figure that was on the beginning, on the right.
do you want me to read on, Eddie?
To the starting point.
Okay, let's have a
The
look. See
I-
what's going on here. So we've got all this.
step
Um,
two.
Step two.
Yeah, we should be able to get this, right?
Higher, that is the right figure. No, higher. Go up.
Up.
Up further.
Yes, this on this figure on the right. This,
So that
this,
that modified active.
yes,
Okay.
yes, this
Thank
one.
you.
I trying to, to, but I make some error. I think tomorrow I will find it. And I think it was it is very important as very low voltage, 5 volt, and there is a brain electrode in
Yeah.
it, and through this
Complete the bias. Current path.
yes,
These are not be connected to.
was being enlarged to a signal that is output.
Yeah, it's
See,
basically a really sensitive little amplifier for getting the like an electroencephalogram EEG.
yeah.
I got one here. If you see it, there's a commercial version that they use for lie detectors, like a polygraph kind of thing. These are really sensitive amplifiers that can amplify very small signals.
Okay.
You can find these sometimes surplus. They're great for reading any kind of biological signals like that.
Yes, but the days of gold, it must be cheaper.
Yeah.
Yeah.
That's what he's trying to do. Yeah.
Yeah, so I have a little amplifier because I see what you want to do. You want to amplify that signal from the sensor. So
Yeah.
yeah, I can send you a little circuit for that.
It's a little like a little
I'll just-
op amp he needs of some
Yeah.
kind.
Yeah.
So, do you want this document to be available somewhere, Pavel, or so?
Yes,
Eddie, do you want me to
this-
read through it, or what? What? Because
this find on internet. This material. This
okay. Let's just have a look and see what's going on here.
He's basically showing how to
Make the board.
how to make the board. Yeah. But I think you should. Yeah. You're going too far. Go back to the section where the bigger box was and the guy was plugged in. Oop.
This one here. This one here. I mean, this one here.
No.
yes,
No.
this one.
No. You had it. You had it. It's just you're going too fast. So go down again, Brendan.
I think I saw a sensor there.
But go past all of this.
Etching the board with
Etching the boards. Keep going.
there's the board.
Yeah, it's going to come up right about now. Yeah, I think this is the stuff that we want to look at.
A recording. You can clearly see that in my case, very slow alpha rhythm. 3-eye blinks and tooth grinding.
Yeah.
You can download the test recording from here.
But is that actually your test?
No. This from I found it on internet.
Okay, gotcha. Okay, gotcha.
That I find to explain the problem.
So that this is you're trying to make it really small and inexpensive.
Yeah.
So this is a
Yes.
more complicated version, right?
Solution is expensive. I
Yep.
must find cheaper one.
Yep, gotcha.
Those the sensor pads there?
Yep, that's definitely.
Yes, there are many sound. I think it is sufficient only 3.
Yeah, you want to use only 3. Yeah, to simplify it. Yep.
Yeah.
Yep. Interesting. There's 2 channels.
Yeah, here we go. Next picture, I think, shows the sensor. Yeah,
There we
it is.
go. Silver plated.
Yes.
Yeah.
So that goes on your forehead, some such way, or on your skull, right?
Third eye
There you go.
and vagal. I think he's putting them on the
Yeah.
vagal nerve
If,
behind the ears and the third eye, right?
yeah,
Mhm.
if you're doing three, you could do one in the center and here on the temples or behind the ears. Yeah.
Uh,
Very
in our
cool.
in our country is one company that produces these sensors,
Yeah.
and I will buy it because it's not necessary to produce it. But my goal is have this right amplifier.
Yep. So it's the electronic box that you need to develop. Yep.
Yes.
Yep. Gotcha. Well, you're talking to the right people here. Not me, but these other two. I don't really do much solid state stuff. I'm more of a tube guy. But um, what that op amp that you're talking about, Paul? What chip number is it? Out of
Well,
curiosity.
actually, I would do it. I got this really neat circuit that is a really clean amplifier that uses two transistor JFETs basically.
Oh, okay. Yeah.
And it'll be perfect for this because it's literally about 50 cents in parts, and you'll get your signal up to what you need. And you can run it on 10 volts, 20 volts, 30 volts, and you just change the circuit. I'll send you the circuit, whatever power you want to get out of it in the end. But if you get up to +2 peak to peak signal volts, peak to peak, you'll be great to plug that into anything you want.
Two volts.
Yeah,
Peak to peak. So it's almost like
kind of
a
like an audio
audio.
signal.
Yeah, I was about
Yeah,
to say that because
yeah.
that's about what you're looking for from a
Yeah.
CD player to power up an amplifier, right? 2
Otherwise,
volts.
the initial signal that you're sensing is just potential nanovolts kind of
So
thing. So you want
so
to amplify that cleanly up to the
yes. So one thing that I described to Pavel yesterday is in my audio stuff, it's cartridge. The signal is ultra tiny with the cartridge on a
right.
turntable,
Yeah,
and then we build it up and build it up and build it up, and we do it with different methods because we can use transformers
yeah,
in inductance, or we can have amplifiers. There's multiple different ways to do it, but they usually have to do it in different stages, right?
yeah.
So basically he's got the one stage and you're just adding another
I'll
stage.
add that second stage to it for sure. That'll
Yeah,
get you up to a signal
that
you can use that's
that he
clean.
needs. Well,
Yeah.
that's beautiful.
And,
And
and
it's
also, Paul, why don't you just add in a white noise circuit too and
Well,
start
that'll be the
experimenting with
second
that?
part. Yeah.
yeah.
Well, it's a funny thing because I've had it in the back of my head. I even have a dentist chair that I had picked up at one point. And I thought maybe I would use it for a sound system and you could change your angle of your
Yes.
chair and everything while you're sitting there.
Right.
Cool. I
That'd
like
be
it.
great. But
The
I
dream
always
of
had
every
it in my head
audiophile.
to actually build a Delta T antenna around the thing and make a little mini mind amplifier, mini Montauk.
Okay,
Yeah.
well, let's do
thing.
it. I'm going to be there soon. I'm
But
going to be there
yeah,
next week. So let's
yeah.
do it.
Okay.
That's
All
awesome.
right. It's been on my bucket list for a long time.
Oh,
I've got a lot of
Yeah.
these back burner
it just
projects.
got put on my bucket list just now. I
All
like it.
right.
And
Yeah, and
next,
then
I can tell you my result if I will be successful to in this with this amplifier.
yeah. Okay, excellent. Yeah, let's do it.
Yeah,
I
definitely.
have some mistake and I must find it and remove it. And I think I hope it will be work. And future work is this sensor combined with mobile phone because it will be more cheaper. That is necessary a special box.
Yep. Yep.
Yeah,
Yep.
if you can use your phone to do all the processing power and then, do those FFTs and all that too.
Oh, interesting.
Everybody's got a cell phone these days, so if you
Yeah,
make an
that's right.
interface that plugs in to your phone, then you can do a lot with it there. Then you got a
Wow.
full supercomputer.
I have a question for Paul.
Go ahead.
Did you work with Dan Winter on the Muse 2 device?
No, not on the Muse. There was some other people. Yeah, yeah.
So that's
Oh,
for
well, the
sale on
Muse
Amazon.
itself. Well, the Muse is a commercial product that Dan used on one of his other Heart Tuner amplifiers. But the Heart
Yeah.
Tuner amplifiers that there were a couple of them on the stage of the way. I didn't work on those. No.
Okay. Yeah, I see the Muse 2s for sale on Amazon. It's about 200, $250.
Well, that's a
Um,
good price for what the Muse does. And again, it Bluetooth to your cell phone, and it has
Right.
all kinds of programs and stuff like that with it. But yeah, I think you could easily make it for a lot cheaper, like what Pavel has there.
Yeah.
Yeah.
Isn't the
That,
problem with all of these devices that you need to shield out the noise that in the environment because it's
Yeah,
picking
you
up
get,
such tiny signals from the
yeah,
brain that it's
yeah,
going to pick up everything else from the local TV and microwave and
yeah.
the neighbor and
yeah. And that's why Montauk, that's why the filters and all that are so
yeah,
sophisticated.
right.
Mhm.
Yep.
Hey, you might find a paper somewhere. I can't remember. I know I have it here somewhere, but I think the guy's name was Ari Visser, Visser. And he had a method of extracting quantum noise out of a signal to hear down, way down.
Wow.
Well, you know what just came to mind is the quantum purifier from Jack Bybee, right?
Yeah.
That because
Well,
that's what their purpose was when they were designed for NORAD was the noise floor thing, right?
yeah,
That's why they're
right.
used from ground up, also, right? Yeah,
Oh yeah.
but they're
Now
big
that
though, so
Visser did.
they're not gonna fit inside a really small thing, right? But that's something also interesting.
Well,
I
yeah,
like.
that was audio in a noise in an audio circuit. This thing I was talking about with Visser is more like he had some method of like crushing a signal. I just don't remember enough about it to sound.
If you tell me his name, I can look it up. I can see if I
It
can find
probably
it.
is looking at very high frequencies, probably going into terahertz and stuff like that to listen to you.
No,
So
no,
it's
it was just the opposite actually.
It was
But I,
low.
that's all I remember that.
Oh,
Visser.
Visser, and then roughly the name of the paper.
noise.
It might have something to do with noise, yeah.
Noise.
Suppression
Amplifiers.
Visser noise cancellation, yeah,
or
that was good.
cancellation, yeah.
Cancellation, yeah.
Suppression is another word.
Cancellation.
And I believe his
Paper.
first name was Arie, I think.
A-E.
No, A-R-I-E,
A-R.
yes. Sorry.
A-R. Like that?
No. The first name is
A-R.
A-R-I-E,
Visser.
I think,
Yeah,
something like
just put
that.
this in, yeah.
Yeah.
Ari, yeah, Visser.
That are
Well, there we go.
extreme.
Acoustic.
This one
Yeah,
here?
that's it. It had something maybe to do with speech coding.
To put that in the
But I
chat.
had another application for it, obviously. So
Get PDF.
okay, I think that might be it. Extreme
Okay.
coding. I remember that term.
Okay, let's just see if it's got it under. I'm not sure I can get it here. Let me just have a look. Get PDF. Request from authors. Okay, let's go back to that one. See if ResearchGate.
Yeah, you'll get it from there.
ResearchGate.
Oh, that's a different one.
Okay, so let's look at that one.
Well,
there.
it wasn't a patent. It was a paper. So
that one there.
I believe.
Okay.
You have to cover all the bases with noise now today.
Yeah.
I'll put in his name in there.
Well, that was you just had it there.
There was a
That one there.
popped up
I'm just trying to see if I get a free version. So pay.
Oh, I'm sorry.
yeah, you put it in quotes. The title.
What about oh yeah. What is the best place to go to find papers available?
Google Scholar.
Google Scholar is quite good. Let's just go to Google Scholar.
Okay.
And that might get it. Hang on. So whoopsie. You think it's this one here?
Yeah, if you put it in quotes, then it's going to narrow it down to just the name of the paper.
Extrema coding.
Extrema, yeah. Put Extrema, yeah. Put a quote before Extrema, and then after apparatus, and that should get you there. That's what I usually do. If I find a paper like that, I'll just put the name of it in quotes, and you'll find where the actual people that made it usually source it without having to pay those academic.
I think it might be. Whoopsie. Download.
Well,
download.
That's a patent.
So here's a patent on what the paper is about. Yeah.
There you go.
Yeah.
Should I send it?
Oh, cool.
So I can send the link in the chat.
Yeah, and maybe email that to me, please, Brendan. The best place to look for stuff is on Yandex, you guys.
Right.
Yandex?
Russian search engine called Yandex. You'll find stuff on there that you'll never find it anywhere else.
Yeah.
Yeah, the Russians always tell the truth.
Streamer codex, blah blah blah. So let's see if I've got the name. The name is right. Viscera.
Yeah.
Okay. So you want to download it, Eddie, and I'll send it to you via.
Yeah, I'll print that out and we'll have a close look at it.
Oh, cool.
Cool.
Yeah, so check that out.
Definitely.
Downloads.
I mean, it may not relate specifically, but it stimulates the process of thinking about it for sure.
Yep, exactly. Very cool.
Shall we finish recording in a moment?
Yeah, I think we're done for now, but I think we'll come back to all of this again. We can dig into some of the stuff. I'd like to actually talk about how a power triode tube actually functions and how it relates to subquantum kinetics. So maybe next time we'll dive into more electronics and go through
yeah,
some
don't
of that
forget
stuff.
people to join the USPA. Well, actually, you don't. It makes sense to join because then you have full access. But I do believe you can download for a fee, an individual paper.
Okay.
And 1986, Preston Nichols, Geometry of Vacuum Tubes.
Yeah.
Yeah, and could you do me a favor? Could you send me like a link to that? That is then I'll have a look. Yeah.
To the website.
Yeah, one of you guys.
It's psychotronics, yeah.
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 Psychotronics.org, yeah.
See, what I say to a lot of people today, because there's a lot of younger people and stuff, and they get into it, they're into plasma and stuff like this, and they want to explore further. But they're missing the key components that were really popular back in the 80s and 90s when a lot of these people like Preston Nichols and Tom Bearden and all these guys were out on the circuit talking about a lot of this stuff. It was a heyday back then. Even Bob Grenier, I said, just go back and look at all those cold fusion things that were happening in the 90s and you'll find gold nuggets. There's gold in those old papers. And
I fully agree with that.
It's really
important. There is a Bedini paper from 1984 that'll blow your mind, actually.
Yeah, exactly. It's important to go back and dig up that old stuff. And then I even go back into the, early days of the early 1900s and look at like what Whittaker, like Bearden was talking about. But J.J. Thompson, all those guys, there's nuggets, and it seems to come into the consciousness and then disappear, and then come into the consciousness and disappear. Like everything has these cycles.
Yeah,
and we're in a renaissance part right now where everybody's just kind of putting this stuff together again, and we're really, really close. We're on the verge of some major breakthroughs in the energy type.
Yeah, that's psychotronics, just as you'd expect it to be spelled. .org.
Yeah, .org.
Okay. Cool. Yeah, definitely. Very cool. Maybe we can, that Bedini paper in particular has got me curious. Maybe we can do that in a show at some point and go through it.
Was it the battery pulsing experiment or the modified Cromway? he had two devices with the modified Cromway getting suppressed. A big suppression story coming from Bearden on that one.
Yeah.
And it really got your curiosity up because of the cold current effect and all these amazing things. And then all of a sudden, Bedini had to stop. So is that the paper you have in mind, Paul?
Yeah, yeah.
It was the Cromway one?
There's a second, I think so. It's a second half has got Peter Linderman too.
Yeah. He's yeah. Cool.
It's probably the only Bedini in 1984 on Psychotronics site. So
okay, we'll check that out. Yeah, because I'd like to go through some of that stuff with you
guys.
Well,
Morey, aren't you a lifetime honorary member?
Yeah.
Good question.
Should be. All you got to do is get your passcode, and you can get on already.
All right. I certainly. My history was they were only conference that would have me. Right now, everybody else rejected, and then eventually the Tesla conference started up, and then it kind of took over on the technology front. Psychotronics was on more on the consciousness stuff and health stuff. Health was very, very popular, and so. Oh yeah, it was. Now, as you say, this our discussion here is deep rabbit hole stuff that makes me puts me into that psychotronics mode. This is the way the conference was. It's like
that's awesome.
Yeah, we had a good time.
Anything goes, right? It was bizarre. I said it's like going to a science fiction convention where everybody believes it's true. Right? It's all over the place, right? So it was
in 2010, Scott Butlick, me, and Al Kaspersky we went down to visit Tom Bearden. We ended up interviewing for 9 hours, a recorded interview with Tom Bearden sitting in his living room.
Wow.
We're in the process of editing it now.
Oh, cool.
Excellent.
So we're probably going to put that out on Psychotronics too.
I think that was my roots encountering him. I think 75 time frame, 75, 76.
And then, by the way, Obolensky spoke at that. This is like the 2010 conference.
That's a good
Psychotronics. Obolensky's paper.
Yeah.
I helped him write that paper. I was with him for quite a while by then. Yeah.
Wow. I actually have it printed out. I want to go through that in a group.
The Mechanics of Time Revisited is the name of the paper.
Okay.
We should do that.
We will. We will definitely do that. Because both you, Paul and Alan, you both knew him, didn't you?
Yeah.
Yes. Yeah. Paul met him at least once, right, Paul?
Yeah, a few times. We went up there pretty well every time we were in New York. We went up there.
Yeah, we had to go up there.
Yeah,
of course.
But I was like I was like his apprentice, if you will. I hate to use the word. He was my mentor since I think '97.
Yeah,
when I first went there. You know who introduced me to Obolensky was what's his name? God damn.
I know Paul Laviolette worked with him.
Well, he came later. Yeah,
Al was there too during.
Eldon Bird, thank you. Eldon Bird introduced me to Obolensky.
Yeah.
Wow, that is so cool.
When Guy passed away, I've got a lot of equipment from him and a lot of stuff that was in his lab. So
no way.
Yeah.
Wow.
Yeah. A lot of cool stuff.
Even
those goggles in the
even his glasses. I got a picture of Al. we got a lot of cool photos. I'll dig some of those up too at some point.
Oh, that would be fun. Yeah.
Yeah.
Tesla.
Sure.
Like, Guy had Tesla wound transformers, big, huge ones in his yard, 2 of them. I was going to take them back, but they're full of PCBs, and they had a hard time just.
Oh, you know who else wanted them?
Yeah.
Djokovic, the tennis player.
Oh yeah,
the Serbian tennis player. He came there. He wanted to take those.
Yeah.
Then to give them to the Tesla museum.
Right.
Yeah.
In Belgrade, but the same issue. They became so dangerous to move because they were going to break probably if they did.
Yeah.
So they ended the guy's daughter ended up having to hire a heavy duty company, hazardous material,
hazmat stuff. So
it cost him a fortune to get rid of those things.
Yeah.
Wow.
Because she had to clean up the property. You know, guy had capacitors and oil-based stuff all over the property.
He had a nuclear bomb. Remember that
Yeah.
console that he had, a launch system? That's a
Yeah,
funny story. We'll save that story.
That's a great story, by the
Save
way.
that story for next
Yeah,
time.
that sounds awesome, you guys.
It was a
Holy
nuclear trigger.
Yeah,
Now, to whet your appetite, he bought a surplus piece of equipment and it ended
an
up
army
having a nuclear
surplus.
trigger in it, which they forgot to take out. And so
no
one day the
way.
military boys surrounded the place with guns and came in to get it.
Holy cow.
Whoops.
Yeah, no doubt. I could see that happening though. Yeah, whoops, we forgot to take this out. I mean,
Yeah.
look at all the stuff that John Hutchison, he keeps buying stuff continually.
Yeah.
I mean, he's got a collection. You've got a pretty good collection back there, but
Yeah,
his
we've been
collection is
talking.
insane.
We've been swapping pictures back and forth of obscure equipment, right?
Yeah, it's very, very
So,
cool.
Paul, do you think we're on an energy breakthrough at the moment?
Oh yeah. Yeah.
Of course
Well, there's
we do.
lots of great energy
I
stuff
know that
happening
all
now.
the pieces of the puzzle are on the table right now, and there's a very few last couple of pieces to put together.
There are many,
Yeah,
many
yeah.
ways to make fusion work.
And there's tons of ways. Tons of
Yep.
ways.
Yeah, exactly. And they're all like the Leonard, low energy ways.
Yeah, and they're not complicated. You
Yep.
don't have to get. I think we overcomplicate it. Look at all these tokamaks and
Yep.
the ITER project in France, like $1 billion plasma fusion technologies. We just need more power. It's not more power.
Well, and for linear, low energy nuclear reactions, you just need plasmoid strikes. The
That's right.
Russians study that.
Yeah.
It's caused them to go in a whole different direction for
You got to
nuclear
go
theory.
small. Yeah, nano.
Yeah, you got to go
not-
small.
Not
That's
big.
right.
Go
Yeah.
small.
Yeah, because the
That's right.
compact fusion reactors, they can be like tiny, even the size of your fingernail, right?
And then you have a CCAN full of them, and you got megawatts of power. Exactly.
Mm-hmm.
And it melts down in the little
Boy, you
can.
could turn them off. That's the beauty of those reactions is they don't run away.
Yeah, exactly. Yeah.
And they don't put out the radiation because they feed on their own radiation and just convert it into energy. That's all.
What do you think of Trump's company?
Those guys,
TAE.
yeah,
Yeah.
those
They're
guys
using
got the right
Aemotronic.
idea. Finally, they're thinking in the right way.
I think so too. I was looking at some of that. Yeah.
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 No nuclear radiation problems.
On my Trump chart that I have, the compact fusion reactor is going to be coming out in about 2030. And that's coming out of the secret space program. It was actually developed by Lockheed Skunk Works originally, and Stavati is connected with Lockheed Skunk Works, so that's why he kind of talks about it in some of the stuff. But it was described to me as a basketball, and
About that
it,
size.
yeah, about that size, and it produced 1,000 gigawatts, a terawatt of power for 1,000-watt input. So it's got an over unity of 1,000,000 to 1. And these things,
And do we have a heating problem?
these things
Big
are
conductors.
perfectly. Yeah, well,
Is
they're
it cold?
they're safe. One thing that I'll explain, when I was in the military, I took a course called Chemical, Nuclear, and Biological Warfare. And we saw the inside of a NORAD submarine, pictures and whatnot they were showing us. And one of the things they showed us was this N generator. So it's like an omnipole generator, but it was producing 10,000 amps of power to power up the batteries. And it wasn't, it was about the size of, it was about the size of a coffin, or maybe a little bit bigger. It wasn't that big. And this is technology that, they've had for a very long time. In 2019, the Pius patents came out, and that's how they're kind of releasing the technology through the Navy, essentially, right? But there's many, many ways to do it. And the way that it works with that is it's spiraling at high speeds in one direction, in the opposite, in the other direction, and then there's a charge cluster that's formed at the interface of them, you might call. And you can do it with 2 or you can do it with 4, essentially, right?
So
That's
just let
how
you know
that
we're still recording, just let you know.
Yep. But does anybody else have any other comments? Maybe we should probably shut it off at some point here. Yeah.
Oh, there's probably a lot more that'll pop into our heads, no doubt.
Definitely, definitely. Well, you can probably shut it off then, Brandon.
Okay.
So-
Thank you, everyone. Hope you
Yeah.
have a wonderful rest of the day.